My name is Madhu Venugopal. It's not here. I'm one of the developers and contributors to the controller and OVSDB projects. And I try to dabble around with multiple other projects in OpenDaylight. So that's what I am. My session is going to be mostly hands-on, but I want to give some kind of an overview of what OSGI is for those who are new to OSGI, and give some high-level representation of why we chose OSGI compared to any other technology out there. And then I promise we can directly go into the hands-on and we can have fun. All right, so we see a lot of slides, and we're all networking geeks here, so we love the RFC style architecture diagram. So I love it myself. So Tom covered this in detail, but to give a perspective of from a developer standpoint, every single block that you see there, they're all OSGI bundles, right, from a developer standpoint. So as you can see here, we have represented them in multiple layers, like the northbound layer, the NSF layer, we call the network service function layers. We have the service abstraction SAL layer, and then we have the southbound API layers. The SAL layer can be either AD SAL or MD SAL or both. If you look at today's hydrogen, you see that both SAL is operational, both in base and any other edition. AD SAL is it's called API-driven SAL, where it's not model-driven. The developer defines them as APIs in the SAL, and after that, those the southbound plugins which provide the service write raw APIs rather than model. While in MD SAL, it's all Yang model-based. But at the end of the day, the idea of SAL is to abstract the services provided by the southbound plugins to the NSF layer up in top, so that the network service functions can be written without any protocol specific thing in mind. It can be protocol agnostic. So that's the hope. And we achieved to some extent so far, but we have a lot of work to do on that area. So the layering that we put here, it's mostly for developers' benefit to understand how the modules interact with each other. But from a OSGI standpoint, every bundle, it's an independent entity on its own. This SAL layer does not mean that it's a privileged module or a plugin is a privileged module. Every module is independent and it's equally prioritized compared to any other bundle, right? So it's a democratic system even inside the controller, and everyone is treated the same, right? There's no difference at all. But what is the real difference is that in an OSGI atmosphere, it provides a lot of good benefits. So each bundle differentiates themselves based on the service it provides and service it consumes. Right? That's the only difference that you will see. As we make progress, we'll start realizing that. And please stop me on any slides, because once we go to the hands-on, it's no stopping after that, right? So, yeah. So the controller is built based on OSGI. It's been repeated multiple times. And for those who are interested, we use the Equinox framework, not the Apache Felix or the NOS version. There are many other frameworks out there, but we use the Equinox. Many questions were asked, why Equinox? It's because Equinox is the reference platform for OSGI. So any new specification for OSGI is implemented in Equinox and then carried over to any other implementation. So we thought it's better to be the reference platform. We start using that. So it has served us really well. The OSGI provides modularity and extensibility, which is one of the most important requirements for any enterprise software, right? So if you write a non-enterprise thing, it's more of a POC thing. We can do without OSGI. We can just write a raw Java application, write multiple jar files, just put them together and run it as a controller. But once you have requirements like modularity, extensibility, ISSU, so on and so forth, you have to really think about a framework that provides you in-service software upgrade. That's one of the most important things. And it should be modular so that you can plug in and plug out components. You can dynamically upgrade a given fix. You can have new algorithms dynamically introduced without needing to reload the controller, bringing down, so on and so forth, right? So OSGI provides all those natively without any issues at all. It's because of the way the OSGI was thought about by the founders of the OSGI. It has strict bundle lifecycle management. Like every bundle has to go through the started state, resolved, and then the active state. And this state management is done by the dependency manager, service registry dependency manager, which identifies the dependencies between multiple bundles and boots them appropriately, right? It's essential for us to provide any kind of modularity, right? And as you said, ISSU is supported by default. And the multi-version support is one of the most critical thing of OSGI, where we all heard of jar health and multiple versions of jars acting at the same time is going to screw up your application. But in OSGI, every bundle runs in its own space or a class loader. That means you can have multiple versions of different libraries can be run at the same time in the same application. So it's perfect. So if you have a new company you acquire and they run a different kind of software you want to integrate, it integrates so smoothly without any issues. And a third-party guy is developing an application for you, and he wants to write a specific legacy library which you use already an advanced one. It works as well because every bundle in its own space, right? And these are the various reasons why we pick OSGI. And so far, it has been great because we already crossed 1 million lines of code, right, in just less than a year. And so far, it's not really bad. It's OK. It's working fine. So those are the reasons why we picked OSGI as our base, right? So I'm very passionate about it. We can discuss about it in depth if you want to talk about that. And the next important discussion is the service abstraction layer. The service abstraction layer itself is an API interface, and the implementation is actually done by the plugins and the layers up on top. But SAL provides you the flexibility to provide multiple protocol to be in southbound, and abstracts all the complexities of a given southbound protocol, essentially, right? So that's the benefit of SAL, whether it's AD-SAL or MD-SAL. And it is one of the most important layers of the controller. And you can see that all the plugins, if you see, take all the southbound plugins, one thing in common is they all talk to the SAL. That's one thing in common in all the protocol plugins, right? The implementation of the plugin itself, whether it's OpenFlow or OVSDB or NetConf, they have their own protocol implementations, but all plugins talk to SAL. That's the only commonality among them. And the controller, by default, supports HA and clustering. Again, there's a small nit there. The AD-SAL-based components today support clustering. MD-SAL, we haven't enabled yet, but I'm sure it's going to come in the next release. We use InfiniSpan as our clustering mechanism. Again, it's one of the hot topics to be discussed. Clustering, supporting partition tolerance, and cap theorem. There's a lot of good research to be done there. So in the controller project and OpenDaylight, we kind of believe in rough consensus and running code. So if you have running code, you win, really, right? So yes, of course, we had a lot of discussions on the clustering over the months, and we haven't come to the real conclusion on partition tolerance as an example. But we have clustering support today, which works with AD-SAL components. Pretty awesome. It works really great. So no questions so far. That's nice. And the Northbound API is another important component we all know because the applications are built on top of Northbound. And I'm going to show two real-life examples of an application which is already implemented with all these APIs in place. So we use Jersey library for providing the REST APIs, and we use JAXB and Jackson as our marshalling and demarshalling support. And as you can see here, right, we use Equinox, we use InfiniSpan, we use Jersey, we use JAXB, Jackson, all open source. So the controller OpenDaylight project itself is built using a lot of other open source components. So it's like give and take, right? We take a lot of code and we give back to the community. It works really well that way.
Any particular reason why Java was used? Because OpenStack, they use Python predominantly.
Well, OK, I can go to the history behind why Java and Python, because Python and Java argument, I'm sure we cannot have it here. And I don't want to have it here as well, right? Because it's a nasty discussion there. But what I can say is that I'm one of the guys who chose this kind of platform, right? So when we did our analysis like a couple of years back, 2-3 years back, we did really research on various available controllers out there, like the Nox, Spox, the Beacon, and so on and so forth. Prema, I don't know if you guys remember that. And there are a lot of controllers there. Among all, the primary requirement that we had was it has to be enterprise grade, right? If we chose a platform, right, if you want to understand how the controllers are running today, it has to be enterprise grade, right? Well, yes, OpenStack is enterprise grade with Python and others, but I had a kind of inch towards Java because I like Java personally, right? Well, I like Python as well. It's not, I don't want anyone to bash me on that. Just that I like Java more, right? And I found it's a bit more structured than Python, right? And coming from an enterprise background, I like structure, right? If it's structured, I know I have control over the problem. If it's unstructured, if it is loosely coupled, I kind of get nervous, right? So that's one of the reasons, right? But it's not my decision, of course. It's a group decision. We all get together. It's been what? It's been 1 year since being chosen, right? And the same discussion has been happening. And as I said, code. If you have a Python code runs, bring it in. Let's talk about it, right? Yeah.
What happens if two people submit the same module? One is in Java and one is in Python. Is there a reason why where you're using somewhere you're using Java and somewhere you're using Python?
Yeah. Okay. The question is, if you have two modules, one is Java and Python does the same thing, right? Whether you, how do you pick? Essentially, we don't pick. If you look at OpenDaylight, as Tom suggested, it's purely based on meritocracy. And you can see today in a virtualization edition, you have three SKU of virtualization edition. We have an OSDB virtualization edition, we have OpenDAO, we have VTN, and we have Affinity, right? Essentially, all of them does similar things, right? Provides multi-tenancy. We didn't say, okay, now OSDB is better or OpenDAO is better. We take all the code in, all our projects, and we let the customer choose what he wants, right? So you write a better implementation, hey, you win, really, right? And just because we are written in Java, does not mean it is run only Java. It is essentially JVM bound. So any language that can run in a JVM atmosphere can work. So Python, in fact, I have applications written in Python which can run in a Python environment and it can just still work, right? So nothing against any particular language. If you are interested in writing code in Python or any language, welcome. It has to be in JVM. Or we have other examples where applications just use Northbound APIs. If that's the case, who cares which language it is? It can be in Perl, right? So nobody really cares about that. And in fact, we have a project called DLX project. DLX is Daylight UX, right? It's a UI project. It is written completely in Python, right? In fact, we use OpenStack Horizon as our base, and it's been done today, right? So because that project has no runtime dependency with the controller itself, because it runs outside the controller, uses REST API as the communication path, right? So that's the short and sweet answer for that. Not so short. All right. So quickly, I want to cover this high-level representation of what is a modular. When you say modular, right? We all must really understand what I mean by modular, because we all read modular code, right? Well, let's give a pat to all of us, right? Because when we write C code, functions are modules, right? We all know that. And came along Sustrup, I think, right? When he introduced C++ with classes and instances, right? Then we said, okay, the module is essentially a class which abstracts both data and methods inbuilt, right? That's a module that's represented, and an object is an instance of a class, it's a blueprint, and so on and so forth. And then came along a package concept where, you know what, hey, I have multiple classes, I want to group them together, so let's put in the package. So we have this com.ibm or whatever, or org.opendaylight or whatever, right? So package came along to organize them into a particular group. So then we have the Java archives, jars, where multiple packages can be bound inside one jar file and given it to the customers, right? That's the next level of modularity. But it's not enough, really, right? Even though we have multiple level of modularity, it's still not enough because of the OSGI issues non-OSGI issues I was representing before, like the jar hell issues, multiple version cannot be supported issues, and you cannot have runtime service binding issues, so on and so forth. And that's when OSGI bundles came about, to solve the real runtime modularity issues of Java, right? And OSGI is just next step of a jar system, where OSGI bundles are all jar files. If you look at running controller, look into the plugins folder, you'll see all .jar files, really. There's nothing different there. The only difference is it also comes with a manifest file, right? Something like this. It's an example manifest file. So as you can see here, the manifest file represents what this package exports, what it imports, and some metadata information, right? This, along with jar files, makes a bundle, really, right? What happens is at runtime, this bundle has been read by the OSGI framework like Equinox and reads the manifest file and realizes, okay, how modular this bundle should be. For example, here, as you can see here, the exported interfaces are allowed, but non-exported interfaces are not allowed, right? By having this kind of strict API requirements, right, what happens is once you know how these bundles are all dependent on each other, it's much, much easier to do the ISSU, right? And what I'm going to do is when you do the demo, right, when you do the hands-on, we can all see how it works, really, right? I hope to cover that. Let's see if we have given time, really. Or I'm here next 2 days. We can discuss in detail if you have any questions about how OSGI is done and so on. I really wish I could have spent more time with the clustering and all the information that we can possibly share, but I know all of us are interested in doing hands-on. That's why I'm going to stop it quickly, and then let's go to the hands-on. Right? And one of the most important things on OSGI is the service registries. So as I was explaining to the gentleman here, the plugin exposes their services, and APIs are all exposed by the SAL layer. It's done using the OSGI service registry. And that was done, we use Apache Felix Dependency Manager just for that. If you look at, we use Equinox for our base framework, but we use the Apache Felix Dependency Manager for that. Yeah.
So the nodes would have to run some client for it to discover the controller and register the controller?
Okay, so every bundle, I'm talking about bundle now, I'm not talking about this one, right? Every bundle, if you open the code, when you go to the code walkthrough, either Tom or Mesa, we can do that, you look at all the implementation bundles, we'll have a file called activator.java. So activator.java has all this magic where it will represent what a given bundle exposes as services and what it consumes as service, right? So that is the real key there, right? Once you express yourself as, okay, I'm dependent on this service and I'm exposing this service, the Apache Felix Dependency Manager knows a priori or how to sequence the dependencies and how to do the ISSU when a given bundle goes down, so on and so forth, right? Okay, good. And that is it. So no more slides. We can. I have slides, but it's going to be hands-on, right? Hands-on, guys. It's fun. It's going to be fun. So before starting, we have some administrative stuffs. So I hope all of you guys copy the images at least to your local machines. If not, please do the copy right now. And there was an issue with the file names when we transported the files between one machine to another machine. It somehow got translated from hyphen to underscore. So please rename the file from the OpenDaylight pictorial underscore to hyphen. Then it will start working. And then you can import the OVF file into your preferred hypervisor, like the VirtualBox, VMware Fusion. So should I wait for folks to complete this thing, or can you raise your hands if you've not done it yet so that I can? Okay, there are a few here. Is it okay? Guys, is it okay if I move on? Yeah? All right, okay. I'll move on. So once you, in fact, all the slides, I think slides are uploaded to some wiki or somewhere, so you can download it. At least you can do it at home as well, if you guys want to. And in fact, I have homework at the end, right? So you guys have to finish the homework anyways. So you guys are okay. And yeah, so log into the VM using Mininet. It's a Fedora VM, and I'm a Red Hat employee, so that's why it's Fedora, right? And make sure that once you have the nice UI, make sure the application is showing up there, because that's what we're going to start playing with. Okay, so I'm going to keep moving, right? Okay. I had to go switch back and forth with the demo on this one, so I'll try my best. So yeah, I have a running same VM in my laptop right here, and I hope you guys can see the font in the back. Is it okay? No? I hate it. Is it okay, guys? Back? Good, great, thanks. Perfect. Huh? All right, great. All right, so I have two terminals open here. One I'm going to use for the controller, and another I'm going to use for the Mininet. You all love Mininet, don't we? Yeah, I'm sure. And yeah, so I am in the, this is the root folder I'm in. I'm getting inside the controller base. So by default, we have copied three folders here: controller base, controller SP, and controller vert. These are the three editions that we have in Hydrogen release. And these are all the pre-compiled packages. It's not source code. And Tom will take you guys through how to download the source code and so on and so forth. So this is a pre-compiled one, which you get as an application developer, really. So I go into the controller base, OpenDaylight, and use the run.sh and start running the controller, right? So one thing you'll notice as a developer, once you download the code, it's fairly easy to get started, really, because we use Maven, right? Maven really is a God-given tool. After you guys have seen the make files, going through all the thing, right? Maven is really cool, where you just do the Maven clean install, it does everything for you, right? If you have good internet connectivity, else because you can download the entire world to your local machine. So have enough space in your disk, and you're good to go, really, right? And if you guys have any trouble during your sessions or whatever, right, just go to OpenDaylight IRC, and a lot of guys there will help you out right away. Okay. All right, the control is coming up, and then we are into the tutorial scripts. I encourage user scripts to start the Mininet because I'll show you why. Use this start Mininet simple. It does a few things where, since the demo is going to be both on OpenFlow and OVSDB, right? So I'm setting up a few things before we start the Mininet, really, okay? Because Mininet as a tool thinks it controls the entire world, right? The OpenFlow world. But OVSDB is another protocol which can control the Open switch on the box. That's why we need to set up few parameters like the set manager, right? And then Mininet is, we all know the Mininet what it is, right? So I'm going to start the script. As you can see, as I connected, you can see the controller is throwing messages about switches connected and so on and so forth, right? Now, let's go back to the slide if somebody wants to take a look at this. And how do I get it up, this guy? Shit. All right, so this is what I did so far. I just started the OpenFlow and this one. All right. And we want to start the Chrome browser and go to the 8080. You would have seen the UI that the controller comes by default with. And we want to go into the Osgi Console and see what are the bundles that's activated. The one I was promised you before about actives and resolved states that we'll see right now. All right. So now let's open the Chrome browser, which is hiding here. Oh, there you go. We're using Chrome because we are going to use a tool called Postman that you'll see pretty soon, which is a pretty cool tool, which you guys can use it. So it's localhost 8080. So once you log in, you can see that it discovered the two switches, and it has the link learned automatically. It's all nicely done UI right here. It's fine. Now let's go to the Osgi console on the controller and do SS and OpenFlow, right? What it does is as I said, the OSGI Equinox. A lot of logs here. It's fine. Oh, come on, guys. You know what? Let's save it. All right, so I turned off the logs, so don't bother us anymore. Let's see if it works. Yeah. So it shows up that we have OVSDB, which is I don't do OpenFlow. Right. So it shows that we have OpenFlow plugin and the OpenFlow library. So this is OpenFlow 1.0. The base controller today supports both 1.0 and 1.3. 1.0 is written using ADCell, and 1.3 is written using MDSAL. So that's why the controller supports both of them. So if you want to run the controller with 1.3, that's the homework for you guys, by the way, right? So I'm going to do the demo on 1.0. You guys are going to go back home, try with 1.3, and that's the idea. And the mininet we have here all supports 1.3 here. OVS, everything upgraded for 1.3. So you guys can try that out. So it's, we use 1.0 for now, and we saw the library and the plugin right there. And they are active now. So that means they're running fine. Now let's go to this one and do a ping H1, ping H2. Yeah, the ping works, right? So off the bat, ping works. That's because we have an application called the simple forwarding, right? Which is kind of lame because it installs /32 across the network and make things work based on the R packets. But it's just an example. It's a sample application. You guys can start using that and see how it all goes, right? That's the idea. So ping works. Any question, guys? No, it's fine. So ping works. Now if you go to the controller, you'll see that we learn the host. The hosts are learned, and everyone is happy. Ping is working fine. The controller's basic application has done its job. If you want to see this one, you can do SS simple. You see that there's a simple forwarding application running on the base controller. That's the idea. So if you guys are interested, just take a look at the code, write a better version of better forwarding, instead of simple forwarding or advanced forwarding, and we'll take it as an open source contribution from you guys. But it's an idea. This is the idea for this one. All right. So once this is done, I want to just showcase. Let's open one more terminal, and let's use some OVS commands. There we go. Sudo OVS OFCTL dump flows S1. Right? So now, as you can see, the OVS OFCTL is the OpenFlow controller command, where the controller has actually learned the ARP messages from the host and installed the /32 entries into OpenFlow 1.0 message right here. So you can see that OpenFlow 1.0 message is being programmed, so it's running only OpenFlow so far. Right? That's the truth behind the story right here. So far so good. It's all OpenFlow. So far so good, right? Now let me go back to my slide. Where is it here? Yeah, so I think I covered all the steps that you guys want to try it out yourself. Now let's go into the interesting part, the OSDB, right? The reason I said it's interesting, yeah, go on. dpctl? Sure. So for those guys who wants to know, the dpctl is the data path command. OFCTL is the control path command, right? Dump flows? Sorry? Yes, one? It's just one? Sure, right? All right, is it okay? Sure. All right. Yeah. Okay, let me go back. Yeah, so the reason I said OSDB is interesting here because we all know OpenFlow is a good protocol. Of course, it opens up the entire SDN for us. But actually, the hidden message is that OSDB is another protocol for the managing the open switch, really, right? That provides a lot of cool things. I will explain why it is so important because the real application that I'm going to not demo, we have to wait for the demo. We have 2 more sessions. One, Brent is going to do a session right after the session, essentially. And tomorrow, Kyle is going to do another session on OpenStack. So you'll see how the OVSDB's Neutron plugin use both OpenFlow and OVSDB to do the entire network association without any proprietary stuff, right? That's why it's very important to understand OVSDB is. And it kind of delivers the goal of OpenDaylight where we are not tied to one protocol, right? We can play with multiple protocols at the same time and really control the network. It's not just the OpenFlow only, right? We all know it's not a feasible solution just to have only one protocol and try to rule the world. It's not simply possible. So the demo is to showcase just both OVSDB and OpenFlow because both works natively in Mininet. If you guys want, if you're interested in SNMP, we have SNMP for SDN. If you're a netconf guys, go with netconf. Everything is supported today by Hydrogen. Right? So pick the right plugins and start playing with that. All right. So now, what I'm going to do now is, let's go back here and do OVS VSCTL show. Right. So OS VSCTL is the vSwitch command, control command, where it prints all the existing switches supported by the hypervisor at this point. So even though Mininet is a good UI tool, it's a good tool, it uses OVS as its data path anyways, right? That's why you can see the S1 and S2 all learned right here, right? Now what we're going to do is, I don't want to skip a step, so let me go back. All right. Let's do the SS OVS DB. You see, we have also OSDB plugins running here, all active. One is the OVSDB. The reason we have a lot of this information is because I'm running another application called Hyperglance, which I'm going to showcase at runtime. So we are running OVSDB and OVSDB Northbound are the default plugins available in base controller today. If you download the virtualization edition with running OVSDB, you'll also have another application called OVSDB.neutron. So that is going to give you the OpenStack integration with natively using OVSDB and OpenFlow. And you can do network association, VXLAN, GRE, so on and so forth. It's pretty cool. You guys should run the demo. So it's running now. So the way to interact with OVSDB is, there are many ways. Of course, the best way to do is via Neutron if you have as an application. But since we don't have an application here, I'm going to just use a Postman as a simple. It's a simple REST API tool. It's right here. So browser-based one. And we have collection. You can have. So Postman is a great tool if you guys don't know about it, where we can pre-configure all the REST APIs, and you can share it with friends. So in our case, we have all the, for testing ourselves, we write the REST APIs using Postman, and save and check it inside in the repository, and everybody in the world can just take it and start using it. Right? It's perfect. In fact, if you go to the OVSDB project, you download the code, under resources folder, you get all these various REST APIs. You don't have to hand code it, it's all right there. Just pick it up and start using things, right? Including Neutron stuff. It's pretty cool. All right, so now what you're going to do is first you're going to connect to the OVSDB server. So OVSDB is a bidirectional JSON RPC channel. So you can connect to the OVSDB server, or the server can connect to the controller. Either ways, both ways supported. So here, I'm going to connect from the controller to the OVSDB. Just showcase it's kind of all. It's not the same as OpenFlow, yes, right? So as you can see here, I don't think you can see that. I'm going to open this further. Is it okay, guys? Is it okay? Back, you can see the text there, right? Few nods. Okay, perfect. I couldn't scroll this one out, but what I want you guys to see is the URL. That is the URL. No, I had to go back. Why am I struggling? It's because I didn't scale mode. Sorry, guys, having VNC issues here. Somehow I'm not getting this stupid thing to work. Okay. Go back home and look at this thing, guys. I don't know what else to do. It's I'm just trying to do that. It's there you go. Yeah, perfect. Thanks, guys. Yeah. I don't have the maximize key and get freaked out here. Okay, it's not bad. Perfect. So as you can see here, the connect is a put REST API. Because you're new to REST APIs, REST API is a simple 4-verb protocol using HTTP, put, get, post, and delete. And there are a few more which nobody uses, so I'm just going to ignore that. So we use the REST APIs to talk to the OVSDB plugin through the SAL via Northbound APIs. So it goes through the, if you look at the first, my ASCII diagram, you saw multiple layers. It's going through all the layers. It goes to Northbound layer, it goes to the SAL, it goes to the plugin, it goes, it's just the end-to-end thing right here. So we're going to connect to the server using the put command. So it connects, we get an ID. As you can look at the type is OVS, and it's host 1, right? So you get the type, you have the ID. Everyone is happy right now. So now what I'm going to do is I'm going to create a bridge on this host 1. Right? So if you look at the post command, if I can go there. Okay, there you go. As you can see, there's a host 1, bridge 1. We're going to create a bridge 1 using the post command. Do a send. You get 201 created here as a response. That means you're good, right? It's good. Let's go and create another bridge. All right, created. We are good. You can do a get to get all the existing bridges. All right. Yeah, everything is fine. We have host 1. We have, you can see the 1 and 2 are the S1s, S1, S2, and these are the BR and BR2. And OVS itself is another connection. So we have all 5 connections right here. Now what I'm going to do is I'm going to create a link between the existing S1 and the newly created BR1, right? So the idea of OVSDB is a management protocol where you can create bridges on the OVS instance, on the using the OVSDB server. You can create ports, connect them together. Now it's like, this is the virtual switching, right?
Integrate to OVS, or is it a generic protocol to manage remote databases?
Okay, good question. OVSDB is OVS as a prefix, right? So it's an open vSwitch database protocol, but it is a very generic protocol in a sense where it is schema-driven. It's a JSON schema-driven. I personally know there are 3 companies already working on using OVSDB to manage their own box. I don't know if it's okay to name them or not, because I don't know if it's public information, but I'm sure it's pretty simple to find it. Come to IRC, I'll let you know. All right? Yeah. So yeah, there are companies who are working in OVSDB who are going to do this. They're doing it already. Right?
So how do you add support if you're not? I agree with you that it's just a simple schema. You can set up your schema or you interpret the schema, whatever comes out of the line. But how do you integrate it into a controller that will actually be able to, if like the host connects to the controller is somebody else's controller, these companies are building their own protocol or extensions to OVSDB. How would that help?
Okay, the OVSDB is a schema-driven protocol where, say, a vendor wants to implement OVSDB and add their own stuffs, so they can express their own schema, right?
Even to the controller?
Yeah. Yeah, they can express their own schema, and things will work like magic. Not yet. In Hydrogen, we are supporting Open vSwitch primarily, right? We support 1 or 2 schemas, but we have a thing working on Helium. For Helium, we want to be completely schema-driven, meaning anybody can come with any schema and it will work like magic.
And you don't need any recompilation or anything?
You don't need any recompilation. That's correct, right? So it's all going to be really exciting times from Hydrogen to Helium. And anybody interested, please come and participate. The OVSDB team is just a very small team in the open source community. So I guess we'll take any code from you guys. Of course, after review, all right, guys? Yeah, we'll review. Yeah, so I'm going to create ports, attach them to multiple. So I'm going to go a bit faster now. So I'm creating ports between the BR1, BR2, the S1, S2. After this is all done, I'm going to show the topology is completely changed on the mininet. All right, so now I did a lot of clicks here, but essentially what I did is I created ports and attached them to the switches, really, right? So now let's go back to the OpenDaylight UI and do a refresh. You'll see the hosts are expired because the pings have stopped. That's good. And you can see that there are 4 switches now, right? Because S1 and S2, we created BR and BR2. They're all connected together, even though Mininet thought we created only S1 and S2, right? So the reason I'm expressing this one is you'll see the exact same requirement. Even though it's so simple, I'm just doing a lame pressing buttons to make it work. But all this, think about making automated in OpenStack environment. You'll get virtual network virtualization like a click of a button, really. So that's the beauty behind it, right? It's all what I'm showcasing here is the building blocks. Using that, you can start thinking of applications. So that's the promise of SDN, where we build the building block, give the controller to you guys, right? You guys build great apps and make it work. That's the whole promise of SDN, and we are delivering it slowly. So the OSDB has done its job. Now it has created the switches, connected the ports. Everything is good here. Now I'm going to go and destroy something. I'm going to delete some ports, right? The original topology that Mininet created, I'm going to delete that port, meaning S1, S2 will not even have any connections right now. All right, delete it, right? Oh, I deleted the stupid thing. It's OK. Let's go and delete this one. I deleted the rule. It's all right. OK, now deleted. If you go to the UI, you'll start seeing the, because I deleted one side, other side is not later. But it's fine. It's all good. Now you can go back and do a ping. Ping will take a different route because we deleted the link. Link is not there, so you'll take a different route, and things will still work. That's what I want to.
So where did it allow you to trace the route?
Sorry, which one?
Can I see the route where it's saving it? It's a complicated route.
Yeah, so those are applications, right? Because the controller provides statistics on all the nodes. It provides port stats. It provides the link stats and whatnot. So now OpenDaylight as such does not have a trace route like functionality, but it does have the troubleshooting tool here, right? Using this, you can go and look at the stats and figure it out. But we don't have an app which does this cool thing, right? But that's what I want to showcase, actually. After this demo, I wanted to showcase this tool. Folks from, what happened? Right, okay. So the tool is called the Hyperglance, right? Stace Ipperson is one of the guys who is developing this. The company is called Real Status, right? So they are actually developing a nice management tool for using REST APIs. So the question that you asked is actually done in this tool. So it's an application on top of the controller. I didn't write it. These guys are writing it and then selling it as product.
But OpenDaylight provides the statistics.
It provides everything that you need, right? Okay. So now we can go back and now start deleting the bridges. So that way we can get rid of the bridges that you created as well. And I'm running short of time, so I'm going a bit fast, right? Again, I did this. But it's OK. It's all good, guys. It's so real, right? Because I'm making mistakes. It's real, right? Yeah. So we deleted the bridge. It's a UI thing, right? I mean, in UI, if you look at the UI, it's kind of one directional, and we can do the polling. So if you do the polling, we can keep refreshing the UI. But again, UI is just another component, right? Somebody should act. I don't think folks are going to use the same UI because this UI is not going to scale for topology. For 3 boxes, it's perfectly fine. For demos, it's great. Even 10 boxes, this will not work, right? That's why things like the Hyperglance, these guys are doing a great job there, right? That's going to scale. I mean, this is a really awesome tool. I have seen it myself where it can do a lot of 3D rendering and everything. If you guys interested, just go and see this tool. I mean, UI is one of the most important projects to me because that's what human interface with the thing for troubleshooting and management is very important, guys. It's very important. Yeah, so I went through this demo hands-on. You guys try it out yourself. You have the VM. You have the slide deck. You have my talk, so you should be able to go through it. And this is the promise of the real use case. So whatever we showcase here is the building block, right? We have the OSDB, we have OpenFlow, we have various protocols. But what is the promise? The promise is something like this. But it's working already. It's not a promise. It is working already. Please stop by for the next sessions. We have the Kyle session tomorrow and Brent session right after this one. Just 1 second, finish this one, right? So once you'll see that the Neutron is an application there, OSDB Neutron, which exposes Northbound APIs, uses the exact same primitives, the OpenFlow primitive, OSDB primitive, all using SAL, using 1.0, ADSAL, using MDSAL for 1.3, and it's all working today in the virtualization edition. Okay, so OSDB and OpenFlow controller provides the base platforms for you to build on, and after that, you guys can develop any application you want to, and we're all here to help you guys out. Yeah, sorry.
Where can we get this slide deck?
Slide deck, I think, is posted in the summit page somewhere.
No, it'll be
Or if you guys want, you can send me an email. I can send it to you guys. If you are curious, right? It's fine. Is there? Okay. All right. But I'm sure it's there. All slides are there, right? So this is the promise that we have delivered here. So I have the confidence that SDN is going to be there. It's not a promise anymore. We're delivering on this. And Hyperglance is another tool which I got thoroughly impressed because I tried it today morning, right? I didn't even prepare for it. Before coming for this demo, he said, "No, hey, dude, why didn't you show it to the community?" It worked right away, right off the bat. So it's pretty impressive. Try it out, guys. This is a very interesting tool as well, right? And with that, I am done with the demos, guys. And the homework, where is it? Oh, so the slide is gone. All right, the homework to you guys is just try out OpenFlow 1.3. Whatever demo I gave, try it with 1.3. It's going to be more fun, right? Thanks, guys.